Welcome, good morning, good evening, depending on where you are, and welcome to our webinar and introduction to ArangoDB 3.9, Powering Graphs at Scale. So in short, what is this going to be about? About 2 weeks ago, February 15th, we released ArangoDB 3.9 with a lot of cool features from hybrid smart graphs, from different analyzers for ArangoSearch, from different new AQL functions, and a lot of different performance optimizations we'll see within the next 45 minutes. And if we have enough time, we'll also see a short demo out there. So just in terms of recent events, just a short shout out to everyone out there in Ukraine and also to our Russian team who are also suffering under the current situation. Me, that's Jörg. I'm CTO here at ArangoDB, so actually in charge of all this, of all the technical, both like light and dark sides of ArangoDB. So feel free to reach out to me if you have any feedback, if you have any wishes or input for improvements. Always happy to hear. And in my past life, I basically been doing databases my entire career. So from my PhD, actually already from my bachelor's thesis onwards. Then I was over at SAP, moved over to San Francisco, and also along this journey, always happy to work in open source companies. So very happy to see a lot of people from the community here as well. So again, if you have like any feedback, any input from the community, please let us know. With that, just for those people who might not be familiar with ArangoDB overall, which I suppose everyone here is, just in short, what is ArangoDB about? ArangoDB is a database which is at its center really focused on scalable graph technology. So we have clusters of over 40 nodes running with our customers and open source users out there. And then I think very uniquely connected by this graph core, we have different data models out there. So we have support for document data model, as you might expect from a document database like MongoDB. And with that, of course, also for key value stores. We have support for graph. We have support for full text search. Imagine like an inbuilt Lucene or Elasticsearch. We have a very scalable graph processing framework based on Google's Priggle framework. We have a very extensive ML and analytics stack. And I think the very unique thing out there, and also like one of the key benefits of using ArangoDB, is that it's not individual database engines. All of those different models and capabilities are united within a single database engine and also within a single query language. So from a user perspective, it's like a single source of truth. You don't have to copy data around between one system and then your full text search engine. It's really all within one system. For the operation teams, less maintenance, and also from an end user perspective, of course, faster performance, because again, it's all handled within a single database engine. All of that, of course, couldn't really fly if you couldn't easily deploy it. This is why we have support for using kuberango, which is our Kubernetes operator, making it very easy to deploy and probably more important, even maintain ArangoDB clusters on top of Kubernetes. And even our own managed service called Oasis is building on top of Kubernetes and on top of, therefore, also kuberango, but it's basically hiding away and taking away all the pain of even managing clusters out there. So even the coolest database couldn't really help you, the most performant one, if you couldn't easily deploy it. This is where we also invest in quite a bit of making the user experience of operating and starting to use ArangoDB as easy as possible. Okay, ArangoDB 3.9. So we can let's actually go here for a second. Let's make that a bit more interactive. If we look through the release notes of ArangoDB, we see there's a pretty long list of features, starting with some core database stuff from like graph features. We'll dive into AQL. AQL is our query language with a lot of optimizations. new server options, and then also our client tools got quite some improvements, especially in terms of performance. So actually, this is all, it's quite a lot for a single webinar here. This is why we'll just focus on like some highlights. But as I said, we'll share the slides later on, and feel free to either ask questions in the chat or also visit here the link and browse through like the details of the release notes. So the first feature I would like to highlight is hybrid smart graphs. And I mean, just whenever I read that, I'm like, okay, hybrid smart graphs, what does it mean? And we are trying to improve our naming. So I hope you'll see that coming up in 3.10. We try to come up with a bit more descriptive names out there. But what are smart graphs about? So before understanding hybrid smart graphs, let's try to understand smart graphs and what they're about. So a common challenge a number of our open source users and customers are seeing is, how can I scale out my graph use cases? So if I do something very naive, I might end up, and we'll see that also on the next slide, basically with a random distribution and random cuts of my graph. That means for large scale graph traverses or large scale graph analytics, where I have to touch upon large portions of the overall graph, I basically end up with a lot of network traffic, because you can see here, if I have a traversal crossing over from one DB server to another, I basically will incur network traffic in one way or the other. And so this is something where smart graph can actually help us. So maybe we could call it smart sharding instead of smart graph, but this is basically where we end up. So naively, if we have a naive setup, this is pretty much what we can see here. The data and nodes and edges might be randomly distributed across an entire cluster. And therefore, whenever doing a large scale graph traversal or graph analytics query, we'll end up with a lot of data traffic. And the animation we can see here right now is how the smart shard distribution can actually help us to minimize those network hops in between. And so thereby, as the query optimizer is also aware of the sharding happening, we can push down a lot more queries to individual DB servers. And this is especially true for one flavor, which we will see in 1 second, disjoint smart graphs, where we know that our overall graph is actually consisting of multiple disjoint subgraphs. Imagine, for example, in large IoT use cases, where people are capturing like all the different network devices. Usually the network devices of each individual tenant, of each individual client will be a connected subgraph, more or less connected. But then in between subgraphs, you'll either have very few links or even no links at all if those networks are separated. And again, I think the key to that is that the query optimizer is aware of that and can then exploit the sharding of data for better query execution. Okay, having that said, let's look into the different types of smart graphs. What we saw earlier is like the standard set of smart graphs, where we just try to minimize the edges going in between DB servers. So the second flavor of it is disjoint smart graphs, where we have no edges in between. So for example, a case where in a multi-tenant setup, it's really separated, and we know those are separated networks, but we still want to keep the overall graph as a union of all those subgraphs, allowing us to do like global analysis over all our tenants, allowing us to capture global statistics out there. So this is a flavor we call disjoint smart graph. And again, the query optimizer is aware of that. In this case, it really knows it can push all the queries down to the DB servers, and it doesn't have to incur any network traffic. The new feature which we have now is the hybrid or even hybrid disjoint smart graph, to make it even more longer than naming. We Germans really like long names accumulating. And this is new in ArangoDB. And in short, it allows us to combine the smart graphs or disjoint smart graphs together with satellite collections. Yet another term. Let's have a short look what satellite collections are about. So in a lot of those use cases, so here, this is the LDBC. This is a standard benchmark, the LDBC social network benchmark data set. We often have small, I usually like to refer to them as metadata classes or information tables out there. So for example, here we have certain tags, we have certain universities, companies, but this is kind of like a very, as it says here, even this is a very static part. Like usually in such a scenario, we are not going to add like universities out there, but down here is a dynamic part. This is the core part of the application, the social network. We have persons, we get different forums, we get different posts and messages. So this is where things are actually changing over time. Whereas here, this is more or less static. And this pattern of having static parts and dynamic parts in your data is a very common use case where often they are describing, for example, sensor locations or other inputs, and we often need to join them together. If we, again, this easily works if we are like a single node environment because we don't have to worry about things. But let's just briefly jump back here. If we are in a distributed environment and this metadata is needed across all DB servers in our case here, we would have, if we would have to decide, like, do we either put the university data on DB server 1, do we put it on DB server 2, etc., etc. And as it's really needed across all nodes, as it's kind of metadata, we would have to incur network traffic then for certain queries from DB server 1, retrieving it from DB server 2, etc., or vice versa. And this is exactly the idea of those satellite collections, that certain data we want to mark as satellites. So they are actually circling around the main data set. And they are replicated across all servers. So we can see here in this graphic already that the satellite collections, they are distributed and replicated across all the DB servers. And especially as those are static, we can easily do that. But even if they are not, so for example, with forums, we might even decide to make that a satellite collection simply because we know it's much less data, it's often requested, it often needs to be joined with all the other data set, and it's not as dynamic as, for example, persons or especially messages and posts where a lot of them might be created within a single hour. But creating like a new forum, this is something which happens at a lower order of magnitude out there. And yeah, combining that, this is leading to hybrid smart graphs where we can combine the smart sharding of the smart graphs together with the replication capabilities for small metadata of the satellite collections. And again, you kind of could do that before, but the key here is, again, that the query optimizer is aware of it and can really exploit this combination very efficiently. Okay, we can actually try that out. And maybe this is something very interesting for also those who are new, but maybe also for those people who have been around for a while. We actually have a large number of interactive tutorials or Jupyter notebooks. So here, just going through, we can see we have like basic introductions to AQL. We got introductions to graph. We got introductions to graph analytics in retail, visualization, then hybrid smart graphs, which is already open there, different graph, different search. So you can actually learn a lot about those different topics using those interactive notebooks. And especially the cool thing about it is you don't even have to install ArangoDB. So this is backed by our managed service Oasis, which, if you haven't done so, it's really the easiest way to get started with ArangoDB. And what we did for those interactive tutorials, interactive notebooks, we basically created a temporary database for you, so you don't have to go in and install ArangoDB first. And then you can explore multiple aspects of ArangoDB. Maybe just one more sentence to those Jupyter notebooks. If you really haven't seen them before, in my opinion, they're a really nice way to combine documentation together with executable code. So if you, for example, are familiar with machine learning and TensorFlow, pretty much the entire documentation of TensorFlow is consisting out of those notebooks. So I can just go in and actually run stuff very easy. And this allows us also, I just, in terms of time, I pre-ran some of them, copying all the data already here in the right places. And now we can really just jump in. Where's the next executable cell? Down here. So for example, come in here and interact with the ArangoDB, create those different collections, and work with that without having to write all this code by ourselves, and so learn about it. So if you're interested, I think this is a really good way to get hands-on experience in terms of time. And as hybrid smart graphs are really just one feature, I don't really want to run through it in all detail right now, but feel free to post questions about it. Next big topic, and very exciting to see that also picking up overall, is search or the new analyzers we introduced in ArangoDB 3.9. For those of you who are not familiar with ArangoSearch yet, so ArangoSearch is really a way for doing full text search across your documents in ArangoDB. And we have a number of users who, for example, use it especially together with the graph capabilities. In the following way, I do a full text search to first identify interesting starting point for either my graph traversals or my graph pattern matching. And then from there, I can basically do the analysis using that, but I can already find kind of the interesting spots across large graphs I want to start with. And how does it work? Those of you who might have used Lucene or Elasticsearch, probably you're familiar with this flow, but basically it works. You can supply one or more collections of documents in ArangoDB, and then have the analyze phase, or this is where the analyzers also come into play. And those then create a view. The analyzers, let's maybe just quickly jump to a list of some of the analyzers which are already implemented in ArangoDB. It can be, for example, text analyzers, tokenizing words with optional stemming, normalization. It can be like n-gram search for fuzzy search or other things. Segmentation is one of the new ones. Geo capabilities were also introduced there. So we basically analyze free text and then create a more structured view out of it. And this structured view can then be queried by the user. The results can be filtered and ranked and then be returned to the user. And so the new part, or some of the new capabilities of ArangoDB 3.9 that were exactly introduced in this phase, where we can create more powerful views out here. So let's see what we can do now. And so I think this is especially interesting for people who work either with the different languages, so mixed language documents. So there's the segmentation analyzer would be helpful, which allows you to tokenize text into language in a language agnostic manner according to Unicode standards. And so this is, as mentioned, if you have a mixed text with different languages, if you have a text with a single language, we probably have the text analyzer with the specific language support already, but in many cases, you cannot really split your documents in that fashion. And this is where the segmentation analyzer can come in helpful. On the other hand, we also got the collation analyzer, which allows you to convert text into language-specific tokens. So again, we see more and more users going into a world with multi-language or different language support. And this is why we also reacted and added those two new analyzer types. As you can see, there's also a very long list of other analyzers already implemented. You can also create your own ones, so custom analyzers. And you can also, here there was a feature introduced in 3.8, you can chain multiple analyzers together into a pipeline. Okay, furthermore, we introduced new AQL functions. So let's have a short look what those are about. especially if you're doing some kind of clustering or analysis, I don't want to necessarily say machine learning, but it can also be helpful for there. You often want to see like what is the distance in between, or like how close are two things together, or how much influence have different data points to each other. And therefore, we often need a way to kind of decay a certain influence over time. And the most common decay functions are exponential, linear, or Gaussian here. And what they basically do for a data point or array of data values, they give us a decay score out there. So for example, here we have the distance, or we have a data point at 41. 40 would be our origin. Then we have a number of other parameters like offsets and different weights. We can kind of control the Gaussian distribution out here. And that would give us a score of 1, which, I mean, in this case, is pretty easy. It's like one away, the way you can imagine it. But the further you get away, the lower that score will get. And this is very useful if you want to, for example, do clustering, or if you want to figure out like how is the influence over especially longer distance where it should decay pretty quickly out there, where it's very within a small neighborhood, we should have a pretty large influence onto the output. Next thing we added, or the next class of functions we added, are vector functions. They allow us to combine the similarity of two vectors. So for example, cosine similarity, L1 or L2 distance, they take as input two vectors, and they allow us to see how close or how similar are those two vectors. And especially if we are going into the embedding space, with, for example, graph machine learning, where another webinar is going to come up shortly, we often are interested in how similar are two embeddings. So for example, how similar are two word embeddings, or how similar are two node embeddings in the graph space. And therefore, we often have to compare the vector or the embedding created for those two. And this is exactly where those functions come in very handy and helpful. There's a large set of miscellaneous features, which we can't really go in here into too much detail. But what I want actually to do is just to go through the list. And now actually feel free to just ask questions right away about features you find interesting. Otherwise, I will just be very selfish and tell you about interesting things I see coming up here. So maybe just as also internal, we started to really build up a larger UI team. For a long time, UI was kind of split between different developers, and you can start seeing that in the 3.9 release. You'll start seeing it even more in the 3.10 release. And so, for example, we already have support for analyzers. So the search capabilities we discussed earlier in the web UI now. We have, for security reasons, improved web interface session handling, and we also have additional fields over the place. And also, just from a debug perspective, there are a lot of small details when you see something wrong in your cluster, where now from the UI tab, you can see quite a lot more there directly, and you don't have to go into statistics or somewhere else. On the AQL side, of course, we also added a lot, and as you can see, a lot of that is coming together with performance. So, for example, upserting with an index hint, traversal filtering optimizations, and many other things out there. We also have an experimental feature for multidimensional indexes, which might be interesting for you to try out. But keep in mind, those are experimental features. We might drop them at some point as well. They're really just out there for us to get feedback. What do you need on the user side? What is useful for us to introduce in the product out there? Then, as mentioned in the beginning, also on the client tools, we improved quite a bit, especially the performance across different tools, from Arango import over Arango restore over Arango dump. So if you're using those to import or backup your data set, you'll also see quite some performance improvements. Okay, jumping back, as said, like if you really want to dive into details, there's also the link to the blog post. So there's a lot more to explore. And also, if you upgrade from 3.8, you should see quite a performance improvement for your queries. Upgrading is the next keyword coming up here. And so for that, I would always refer you to the upgrading chapters in our documentation. But in short, with ArangoDB, if you have a cluster, it's always a rolling upgrade. So you have like if you're running a cluster, you experience 0 downtime if you do it correctly. The probably most easy way to do things, if you're thinking about which deployment type to choose, is probably running it on Kubernetes. As said, this is something we also do pretty heavily internally. Second option out there, if you don't want to run it, is using the starter. And then, yeah, the last more cumbersome option is actually to deploy it manually. So I would actually urge everyone, especially if you're using a cluster, to either use Kubernetes or the starter option out there. There are some incompatible changes. So we try to keep that to a minimum, but it doesn't always 100% work. But you should actually, I would always recommend try to browse through here and see what's going on. So you should be aware of this. Section, but it shouldn't stop you from upgrading. Let's maybe just briefly go through. So there's a really old deployment mode, leader follower, which has been deprecated, I believe, already in 3.5 or somewhere out there. So this is not supported anymore. Furthermore, we raised the minimum architectural requirements towards AVX instructions. We are, for those people, there were like some community requests over the past weeks of people using M1 Max and Rosetta, which doesn't fully support that. We will actually provide special build Docker images without that, so you can still develop on your local Mac. This should be available starting probably next week. So feel free to also reach out if that is a challenge for you right now. Or otherwise, you'll see there's an open ticket on the community GitHub repo. Furthermore, the extended naming convention, maybe that's still an interesting feature we could briefly talk about as well. So we extended the naming support for database names to allow UTF-8 characters in general. That's actually, maybe it jumps there here in the documentation. So in the traditional naming conventions, we only allowed like a limited subset, and that led to issues for some people who are really generating those names based out of other characters. And currently, this is the first piece we are introducing there, and this is why there's still like some watch outs, and this is why you should opt in explicitly, as for example, not all community drivers are supporting that yet. This is one of the challenges. I think it's actually a great challenge, as we have a big open source community. We do not control all the drivers out there, and to not break the drivers, we for now made that an opt-in feature. And with 3.10, we will also extend the support for collection names. So I said in 3.9, it's just for database names. And then we'll also move it over as probably as a default in 3.10. So just stay tuned for that. But those are some of the changes which might lead to issues if you're, for example, using an open source driver which wouldn't support that in 3.10. Then on the other hand, on the AQL side, we introduced an explicit limit. So previously, you could actually just have like a very deep nesting of queries. And that could lead into issues if you had like if you would exceed like the memory trace down there it with too many levels. Now we added an explicit limit of 500 levels deep, which for any queries we saw out there is actually sufficient. Similarly for the number of execution nodes. So previously that could have led to just queries aborting. Now you just at least get an explicit error out there. But let us know also how that works for you. From our perspective, this actually leads to better user experience because you get an explicit error. Okay, with that, we also have an explicit section for driver developers of the API changes. So if you are a driver developer and you want to upgrade, for example, for the new UTF-8 feature we talked about earlier, please have a look at this doc. It's linked here, and that should help you to like update your driver. And also, please reach out to the community. We are always happy to help you in upgrading, providing those informations also upfront, providing test environments, test versions. So please reach out via the community Slack, via email, Twitter, or whatever is your favorite communication channel out there. And that actually, just as a reminder, we also have an end of life policy. 3.6 went end of life last year, and 3.7 will also be end of life around May this year. I think officially it's May 22nd, but we time it with like a last release of 3.7. So expect that to happen sometime around end of May. And there again, we have a link to the homepage where all the end of life material is listed. Okay, with that, it's kind of the status quo. Let's actually turn to the future and let's discuss a little bit what's coming on the next 3.10 version and what's coming in the future. So we have continuous improvement on the developer experience, on the user experience. As already mentioned, the user interface documentation team is really ramping up. So expect some changes in the documentation. And also on the metrics side, we are continuously trying to add more metrics. You can call that operator experience maybe to make it easier for you out there. Next, in terms of data model, in 3.10, we are working on enabling the full text features, or at least a large subset of the full text search features using a normal index. So right now, as we saw the flow with the analyzers and views, this might be a bit cumbersome to set up, but for a lot of the capabilities, you will be able to use that throughout a normal index in 3.10. And again, indices have the advantage that the query optimizer is aware, so the query optimizer can also choose to pick that index if it makes sense. Next, in terms of query capabilities, as said, we'll get a bit more sane in terms of naming. We'll introduce enterprise graph. This is when you might not benefit from the full smart sharding feature, but you still have a distributed data set. And so enterprise graph will just be the enterprise version of the community graph. So as the name suggests, be only available in the enterprise edition, but they're just out of the box provide better performance for the graph features out there. In terms of clusters, we'll introduce probably first version of like optimized replication, and secondly, read replicas. Right now, when you might be using a one shard or also just a normal cluster, you will only be working together with the leader out there. In 3.10, you will be able to contact also the replicas, which are only there for fault tolerance for now, for having, for example, long analytical read queries and not have this workload on the cluster, on the main leader in the cluster as well. So kind of allows you to utilize your cluster better and also to have write workload not interfering with your more analytical read workloads. Also, we are improving the auto rebalance. So if you have a lot of failovers, nodes might go, or you might increase your cluster size. And also the resharding features coming up in 3.10. This will even be coupled with a first notion of topology awareness. So especially if you're running in some cloud setup, for example, Kubernetes, where all the topology information is exposed. This is one physical machine. This is one rack in a data center. This is one aisle in a data center. ArangoDB can actually, or you can configure ArangoDB with policies to make sure that either your data is as close together as possible for performance benefits, or actually spread out across different fault domains for highest fault tolerance out there. Probably a very big and highly requested feature has been the ARM support. So we are already testing that heavily internally and also on our managed service Oasis. But 3.10 will come with ARM support out there. So all of those of you who are on M1 or want to use, for example, Graviton or other cloud instances with ARM, I think this is going to be a cool feature, especially as those instances are usually cheaper than the x86 ones. Beyond that, so this is our scope towards ArangoDB 4.0 or maybe ArangoDB 3.11. This hasn't been fully decided yet, but just kind of an outlook into what we are working otherwise. GQL graph query language. I think this is going to be kind of the standard default query language across all graph databases. So we are part of the consortium with basically all the other graph database vendors out there. And so obviously this is on our roadmap and working on the first implementation already out there. Pregel 2.0, so we'll improve our Pregel framework and implementation. We'll supply you with triggers and change feeds. So just you can basically imagine you're building a Kafka pipeline, say like all the changes I'm doing to any document I want to feed into this Kafka pipeline. This is something you can do with this feature. We'll update our overall cluster infrastructure, also enabling us distributed transactions, and we'll also update the V8 infrastructure. So the user-defined functions and fork services will be faster and also closer to your data. So stay tuned for those updates here. In the ecosystem, we are working on like the new Kafka 2.0 connectors. We are already released, if you haven't seen that, last month, the new Spark 2.0 connector. So also kind of heavily working and extending our ecosystem team. So if you have any cool project in the ecosystem, we have seen Apache NiFi, for example, Spark, Kafka, were already mentioned. But if you feel there's anything else out in the ecosystem you would like to see supported with or on top of ArangoDB, please let us know. Please reach out to us, or at best even create your own implementation. Happy to promote that also as an official project in the ArangoDB community. On the ML side, we are working on our new updated graph algorithms library, so graph library 2.0. So also stay tuned for that. But most important, and this is now where you actually have to get active, is what are you looking for in 3.10, 3.11, 4.0? So what are the features you have been missing or would like to have featured in this roadmap in one of the next releases? What are the pain points you're seeing with ArangoDB out there? Feel free to, just put in the chat. I think that's the easiest. Let me see if there's anything in the Q&A. No open questions. Everyone is happy with ArangoDB as is. Everyone is happy with the roadmap as is. Okay. Exposing more options wherever there are variables. That's fair. So this is just jumping back maybe to both the 3.9 release as well as the 3.10 upcoming 3.10 release. Let's briefly jump here. We have so for example, we are trying to expose more options. Very good points. So we are, for example, already exposing a lot more RocksDB options underneath. For GOS2, you'll see big changes upcoming in 3.10. Happy to already share all the work which has been done, but for example, there will be a quite big overhaul for the GOS2 support in 3.10, which is actually already merged. So feel free to take one of the nightlies. That's also yet an interesting point. If you're not familiar with ArangoDB yet, you can go to downloads. I always take like 10 clicks. And get one of the nightlies out there here, where we basically, it's not really nightly, it should be like bi-nightly, but you can pull one of the latest images we are currently working on. And so with that, you can do that either for our devel. So this is what will become 3.10 at one point, but you can also do it for the nightly releases for the different stable branches. So 3.7, 3.8, and 3.9 for now. And there you'll already see quite some improvements for the S2 support. Graph or directory systems for collections, including QI. What's coming also in 3.10, try to kind of keep that as a surprise, but as the question is coming up, is a new graph or updated graph visualizer. So also based on new libraries with more support. And then what, if I interpret that correctly, a directory system, you mean ways of kind of structuring different collections in the UI, and also in kind of, yeah, where you can give access to like a folder of different collections, right? Yeah, that's a very cool feature. I could introduce that into our APM board, because I think it would help a lot of people. I would suppose this should also be integrated then with a permission system, making it easier to give permissions for a particular subset of collections, or yeah, subset of views then, as well, as it's not only going to be collections. Any more questions? With that, you can also, as said, always just reach out through the community Slack. Happy to get feedback there as well. I mean, in the end, we're developing ArangoDB not just for the sake of developing ArangoDB, but we really want it to be used. So please let us know what is the best way, the features you're looking for, the pain points you're having, so we can really make sure you have the best experience with ArangoDB. And otherwise, yeah, please go out there, either test the notebook, test ArangoDB 3.9 on Oasis, try to get your hands in there and just explore all the cool new features out there. Thanks so much for listening, and talk to you soon. Thanks.